In this video, I just want to do a quick overview of this concept called slope. Slope is an interesting feature of a line, and it's a concept that describes the steepness and the direction of that line. Now, there's a few other ways to view it in terms of how we want to calculate the slope. One way that's commonly used is slope is equal to the change in y divided by the change in x. And so what you'll notice is that slope is often described as a ratio, or a fraction, comparing two numbers, although we'll see that it doesn't always have to be represented in that way. A common phrase that a lot of students use to remember it is it's rise over run, but I put those in quotes because the term rise is very specific and often not adequate in explaining what's happening in the line that we're analyzing. And run is also somewhat vague because it doesn't really indicate direction. And we'll see that direction is very important when we're determining the slope of a line. So let's start with this first example. I've got 2 points, and if I'm to determine the slope, which we represent with this lowercase m, if I want to determine the slope, what I need to do is determine the change in my y coordinate, and I need to determine the change in my x coordinate, and I need to describe them in this form. Now, it doesn't matter which point you start at, but what does matter is that you pay attention to the sign of the change. Moving upwards would indicate that we're changing in a positive way, and so we would want to represent that change with a positive number. Moving downwards would be represented by a negative number. In the x direction, moving to the right would be indicated with a positive number, and moving to the left would be indicated with a negative number. So the change in our distance needs to have some directional indicators. So it's often conventional to start with the point on the left, so we'll do that. I'm going to start at this point, whose coordinates are -3, -3. And in order to get to the other point on that line, we note that I would have to rise 4 and move to the right, or quote, run 6. And so the slope of that line we can describe as being equal to 4 divided by 6. Now there are a couple things to notice. One is that 4 divided by 6 is a number, it's a fraction, that has different representations. Another representation is 2 divided by 3, if we reduce that fraction. And 2 divided by 3 is equally valid in describing the slope of this line. Because, for instance, if we started at the point on the left and rose 2 and moved to the right 3, we would get this point here, which is also on the line. And if we follow that pattern again by rising 2 and moving to the right 3, we would get our new point. And so representing the slope in different ways is often useful because it can get us more points on the line, sort of fill in information in the in-between that we didn't have originally. Now, as I mentioned, slope can be determined by starting at any point and moving to the other one, as long as we pay attention to the signed differences. So another way we could have gotten the slope is by starting with the point on the right and imagine moving to the point on the left. If we do that, we would be moving downwards a distance of 4. So I would have to indicate that with a -4, and to the left, a distance of 6. So I'd have to indicate that with a -6. But as numbers, these 3 fractions are all numerically equivalent, because a negative divided by a negative is a positive. So the slope of a line can be represented in many different ways, and depending on which way you represent it, that will indicate sort of the direction you're moving as you go from one point to another, but also, I guess, how big of a leap you're taking when you move from one point to another. 2/3 we can see is sort of the smallest pattern we would be using to get as many nice lattice points on this grid, whereas 4/6 would get us points, but they would be more spread out. And so lastly, we'll look at another example where we can see at a glance the direction of the line is somewhat different than the one on the top. The one on the top moves from the lower left-hand corner of this coordinate plane to the upper right-hand corner, whereas the one on the left here moves from the upper left-hand corner to the lower right-hand corner. And so if I take 2 points on that line and analyze the slope, what we see is that moving from the left point to the right point, I would have to move downwards 2. So I have to indicate with a negative. And to the right 4 rather. And so I can describe my slope as negative 2 over 4. And the fact that our number ends up being a negative is an indication, or is a result of the fact that this point is moving from the top left to the bottom right. And one way to think about that is that your change in y is always going to be negative, because you always have to move downwards in order to get to a new point if you're moving from left to right. We could also reduce this to negative 1/2, and by doing that, we see that we could get points in the in-between. So hopefully this helps in explaining how we can figure out the slope between 2 points if we have a graph in front of us.